Okay, good morning, kids. In today's class, we will discuss the problems related to revision of laws of motion and friction. So as we know, the wedge constraints is something very, very important and plenty of times they've asked in advance. So there's all possibility of asking some questions which were not available in most of the books. I brought them. Let's discuss them. Around, I think, some 8 questions I have. We'll try to wind up all the 8. This is a problem which, if you see it, the wedge, yellow color wedge is usually fixed. We have done so many problems. Hope you can remember. We have done so many problems where the yellow color wedge will be always fixed and the other wedge in the block will be moving. That is natural. Let me make this yellow color wedge also free to move. Then what conditions will come? Very lengthy. At least I'll share the method. I'll write the equations. I'll write the answer. You try to solve it. Okay, first think on it. Okay, the system is released from rest. System is released from rest here. Now, in what naturally, out of the block, how the green color wedge, how the yellow color wedge will move, or ABC we can call it. So this will be A. And this is C. Okay, the symbols also there, ABC. So first go for free body diagram, then analyze naturally the system released from rest, how do they move? Okay, I'll begin now. So let's take help of the arrows. This will be the normal contact. This will be normal contact, say N2. Then the weight of this will act. Its weight. Its weight will act. Then this normal contact is N1, and that N1 exactly opposite to that, I'll show it here. And the weight of this mg. The weight of this also will mg will act, and here also some normal contact. Okay, first we are giving the list of all the forces that will be acting. Now we'll give the name. So let this be N1. Similarly, an N1 force will also act here. Equivalent opposite here. Normal contact will also come. Okay, if this is N1, this will be N1. This is mg. This is N2. This is M0G as usual weight, and this is N1. Okay, I think it's quite things very clear, no? This will move in this direction because N1 sin theta will act on it. How to describe the motion of this? So I'll describe their motion with respect to ground. They will have common acceleration along y-axis. Why they will have same acceleration? I think acceleration along common normal should be equal because this block C will be in contact with the wedge B. So the normal reaction, in fact, non-zero. So they must have same acceleration along common normal. Then because of this, okay, this will take N2. Yeah, I made changes here, and this will be acceleration AX. Now you can ask questions, sir, why this will not have horizontal acceleration? How the net force is acting vertically down? Here, component of N1 will act along positive x-axis. The resultant of weight N1 and the resultant of N2, the N2 mg and resultant of N1 will act vertically down. So therefore it will have acceleration Ay, and N1 sin theta will be towards right. So let's describe the motion like this, and we'll write some equation. So we may get some help from this. So N1 sin theta is equal to max on the wedge A. This is. Similarly for the wedge B, N1 sin theta is equal to max. Then along y-axis, I'll continue further. Along y-axis, mg plus N1 minus N1 cos theta equal to ma1. Then on the block, these are the primary equations. These are the primary equations. So this will become m naught g minus m2 equal to m naught ay. Okay. The symbols. Let me add up these two. I think there'll be a better idea. Let me add up these two. Adding up these two. We'll make it one equation. M naught g minus n1 by root 2 equal to m plus m naught a1. So what I did is like, I'll call this as equation 3. Common acceleration along common normal must be equal. Acceleration along common normal must be equal because the block will be in contact with C.
Sir, for wedge A and B, sir.
For wedge C and B, that's what I wrote it. No, block C, there's a wedge B. No. Okay.
Sir,
Where all
same acceleration for wedge A and B, no, sir, along x-axis.
Yeah, definitely. Because what is the force acting? N1 sin theta on the wedge B, N1 sin theta on the wedge A. So I should put same acceleration.
Okay, sir.
Yeah, this is very important because we do think that because of block, okay, that one. Let's not bother who is there on top of it. Net force on the wedge B, N1 sin theta, x-axis horizontally. Net force on the wedge horizontally, N1 sin theta. Okay. So what is the thing? Assume that. So we are assuming that the wedge B and the block C are moving vertically with same acceleration ay, and the net force on the wedge B and the wedge A along x-axis is 0. So therefore, and the force is acting N1 side, and so they will have same acceleration. I think this is some. I'll write that so that it will do. So assume that wedge B and C will move vertically down now. Why we should assume? Because N2 is non-zero, so acceleration along common normal must be equal. Acceleration along common normal must be equal. Okay, this is I think now for the wedge A and B, what is the thing you can write it? N sin theta, N sin theta. So there's no problem. That's why I wrote separately this one. Okay, we have this much here. No, what is a look, let's analyze what are the unknowns. What are the unknowns? You start counting unknowns. N1, N2, AX and AY. Am I right? AX, AY, N1 and N2. So we need more equations. So for that, again, the same idea. Now let me describe the motion of the wedge B relative to the wedge A. Motion of the wedge B relative to the wedge A. So I think we have to be a little bit careful here. I will go to the next set of the problem. I need only diagram. In the next set of the diagram, what we do is like, describe the motion of I will take it out all these things, so it will trouble you. No. So describe the motion of the wedge B along the incline or with respect to wedge A. Let that be AR. So as usual, this will be normal contact. And we know this will be acceleration AX and AX. Then let's I think I need not to show all the forces, just you can know what are the N2 is here, no? I think it also will come into picture. What is the force that will act along the incline? Mg sine theta plus N2 sine theta. And the forces acting perpendicular to incline? Mg cos theta plus N2 cos. I think these are the things. If you stand on the wedge A, then you don't see relative motion between the wedge B and the wedge A. If you stand here, then you don't see any relative motion along this direction. I think this problem is very important. That's why I just picked up. Earlier, I was standing here, then I said, okay, there is no, because these two are in contact, and because of that, acceleration along common normals should be equal. Now, what I'm going to say is that along this direction, acceleration should be equal. Provided you should know what is the acceleration of the wedge B and acceleration of the wedges, then you can write here also constraint equation. But we don't know, all the unknowns are there, so therefore I'll use other methods. So let's write the equation now. This will be the next part. Mg sine theta plus N2 sine theta. Pseudo force shall we apply it? In what direction pseudo force should be towards right? I think pseudo force we made a practice of showing it thick line. Thick arrow is what I used to follow every time. No, even the pseudo force component will also act. MAX cos theta equal to M into AR. It should be capital M plus small m plus M naught or only M. We are discussing only the motion of the wedge, not the wedge B and the block C. Only the motion of the wedge B. So this is the for the wedge B along the incline. And then perpendicular to incline, what are the forces? N1 plus MAX sine theta minus Mg cos theta minus N2 cos theta equal to 0. This is for wedge B perpendicular to incline. Okay. This only will I think will simplify because theta they know theta is 45 degrees. Then I'll write it. Okay, anyway, no, we'll further this one. This will become Mg by root 2, N2 by root 2, MAX by root 2 equal to MAR. So this, if I write it in little bit systematic way. Equation 4. This is N1 plus MAX by root 2 minus mg by root 2 minus N2 by root 2 equal to 0. Equation 4, equation 5. Still we are unable to do anything. Still we are unable to anything. Okay, let me do one thing. N1 by root 2, shall we write MAX, N1 sine theta, or N1 sine theta equal to MAX? I think now let's see any help. I think complete description is available except question. See once, it's now only simplification. After this, only simplification. Putting that equation in this, putting this equation in that. One more, I'll show it. Put 1 in 5. Okay, I'll scroll down. I'll go for the next part of the problem. Root 2 N1. What is N1 is equal to? MAX by root 2. So shall we do one thing? Here, this equation will put it. N1 equal to how much will get it? Root 2 MAX. Already root 2 is there. Root 2 into root 2 will substitute. So put, after this, it's a pure simplification. I'll feel like. Now comes the calculation. One more equation is there. I'll show that. Okay, now we'll go for, I will retain this much here. Now put 1 in 2. Put 1 in 2. So what is the value? Root 2. This will become MAX sine theta minus MAX minus mg minus N2 equals 0. So it will become, I think, 2 MAX plus it is plus MAX minus mg minus N2 equals 0. So this will become 3 MAX N2 equal to 0. Call this equation 6. Now one more. Look at the motion of this one. What is the acceleration of the wedge B along x-axis? Shall we write any constraint equation? What is AX? Come back. What is AX here for the wedge B? Acceleration of the wedge B along x-axis with respect to ground. What is AY? Acceleration of the wedge B along y-axis with respect to ground. What is AX? Acceleration of the wedge A with respect to ground along x-axis. I think if I don't mention anything, it is understood it is there with respect to ground. Okay, let's write some equations here. So from here, acceleration of B, go back to relative motion, acceleration of B with respect to A along x-axis equal to ABX minus AX. What is ABX? Will be AR cos theta, towards right positive. Acceleration of the wedge. This is what AX. What is this? This is minus X. Hope everyone is able to understand. So many times you have come across this. So AR by root 2 is equal to 2X. I think there's a one very fundamental equation we are able to predict here. So now I think we are in better position. So what is AR by root 2 equal to? This is the equation 7 you write. Similarly, I want AY. Can we write AY with this help of this? That AR sin theta only is what AY, no? Acceleration of the block or acceleration of the wedge with respect to ground along y-axis. AR sin theta only. AR sin, sin theta is what? AY. So I'll get relation between now AR and AY. So after this, what to do with all this one? We know AX. We know AX. Do we know AY? Yes, we know AY. Then what are the unknown things will come? N1 and N2. I think we have to get first expression for AR. If you get AR, then all our problems will solve. So what to do for AR? AR is here, no? AR is here. AY, what you can write it here? So all these equations are so many are there. Okay, this together we added up, no? So AY you can write it as AR will get in terms of N1. And next we have N1 also in terms of that one. So no, sir, I don't know N1. N1 again you have to going to bring here. N1 sin theta, what with that one? We should replace N1 into derive an entire expression for AR. I think you can manage. Now we have more equations than unknown. Anybody, value of AR? N1, what you write it as? AX by root 2. Substitute 1 in 3. Replace N1 in terms of AX. Then next step, what we do? AX will write in terms of AR. And AY in terms of AR. We'll solve for that. We'll get AR. So what shall I do now? Put 1 in 3. Put 1 in 3. Then 1, 7, 8 in 3. Equation 1, 7, 8 in 3. We'll solve for that. We'll get expression for AR. I will later on you check it. I think this everything, let it come in order. Here only will wind up. Now what is our next part? Put 1, 7, 8 in 3. Okay, we'll proceed like this. Put 1, 7, 8 in 3. Solve for AR. So AR will be equal to, I already solved it. So I made it ready so that we can save time. Equal to 2 plus root 2. But still advisable, better you work out once. You know my maths that not that strong. This is the equation 9. Okay, once you get AR, I think you will get all the things, no? Now what you should do, substitute all that value of AR in the equation 7 and 8, you'll get AX and AY. I think that was the question that was asked to get the accelerations. I will write down acceleration AY is equal to it's very simple. After getting AR, okay, you do one thing, just substitute here, you get AY. Substitute here, you'll get AX. Okay, this will be AY equal to 2m plus m naught g by now what about AX? AX is very simple. AX equal to AR by 2 root 2. Again, we have to simplify it. Say same thing, it will come. It will be this will be m plus m naught g check calculation. 2 root 2 is there, no, here. This will not be there. Okay, you see, these are the answers. Now you can find out these are things what he has asked. Now, a little bit lengthy, but I just wanted to give that acceleration along common normal will be equal. After class, you can verify nodes once. Very simple. So you need not to bother. See, why I brought this problem is like, we'll get scared. In a given problem, you can describe the motion of wedge B with respect to ground and also with respect to ground or also with respect to wedge E. The motion of the block B or the wedge B, you can describe with respect to ground and also with respect to wedge. We have another method. What is another method? We'll just assume that the acceleration of wedge B is somewhere in this direction. Acceleration of wedge A is like this. Then acceleration along common normal should be equal. Solve it, you'll get the answer. So 3 approaches is what you have. So whenever that block sliding on the wedge, no, let it be. You can manage. I'll go to the next question. Just send me, I think this will help you in WhatsApp. You just message. I'll send this one because all this will help you a lot in revising concepts. Other notes, everything is uploaded in app shortly. It will, by Sunday evening, everything will be available for you. All we discussed 1 week back also will be available. You know to bother about that. Now come for this one. A very beautiful question. Try to, he's asking, so there is a pulley and the pulley is, supports a frictionless pulley of weight. There's a weight of the pulley is there and there's a length of the thread is given. This is the length of the thread. There's a pulley and I'll suspend by a weightless rod and here's the block. Is asking force exerted by the pulley on the string here, this force per unit length, the last part. How much of normal reaction per unit of its length does the string apply on the pulley? Force exerted by the string on the pulley. I think that's a very rare problem. Usually the string is massless, inextensible. We say goodbye. After that, we never bother. In fact, the string will also exert force on all surfaces which it comes in contact. I think this is a very, very fundamental one. It's applicable even for string also. It is applicable even for string also. Not only this. Okay, let's get into the problem. So here the length of the string. So this, shall we take it L by 2? Okay, let this L by 2, L by 2. I'll use 2 diagrams. This diagram, let it be as it is. It will not be lengthy like previous problem. Don't get scared. Okay, now this will be L by 2 and this is L by 2. Let the angle made by the string with vertical. So this will be so take this is theta. This will be theta. Here I'll show it because everything will be messed up there. Now, how the tension should always act away from the body. Here you show it. There's a tension. Component of tension T sin T cos theta, 2T cos theta by 2, 2T cos theta, sorry, should balance the weight of the pulley. and the weight of the block. There'll be normal contact will be acting. What is a normal contact, sir? Like what you mean to say? Here, the string will exert force on the pulley. In turn, the pulley will also exert force on the string. I think this is something we have to justify with suitable diagram. Here I'll bring it. The rope, let me show it. Something. Oh, it's too big. A possibility of asking this rope exerting force on the pulley which is in contact. Okay, this much is there. So where it is in contact, it is in contact only in this region. Afterwards is not in contact. Only a small part of the segment of the rope will be in contact here. No? So here what this rope, it will exert force on the pulley like this. Really, the first time when I'm doing this problem, I took almost half an hour. I think these are the questions which comes in advance. You have to put a lot of effort, especially a question of like this, because the idea like this is what you are supposed to imagine. I don't think so. How many of students will manage? If it idea strikes, okay. Idea doesn't strike, I think you have to fight with it. Now look at the what are the arrows? Force exerted by the. These arrows are force exerted by the string on the pulley. These arrows are force exerted by the pulley on the string. I think this resultant will be internal only. So for pulley, for pulley rope behind the block, this force will become internal. So therefore, I'm just going to write a very important equation. 2t cos theta should be equal to weight of the pulley plus weight of the block. Weight of the block will act here. Weight of the pulley, there's a tension. This is theta, this is theta. Okay, what all that force acting between the pulley and the rope will be internal, because I'm defining the pulley block and this part of the string as an internal. So this is one system. So I need not to bother about those forces indicating the equation. I think we know weight of the pulley, weight of the block, but we don't know cos theta. I think this distance is given. Length of the string is, and the distance between these 2 points is also available. Level at distance 10√2 meter. So this total distance is how much? 10√2 meter. So shall we define cos theta from there? Directly I'll get the tension. Tension the rope. How the tension will act? The tension will act here. I think you have to be careful. Now the tension here will act here. This is a big headache for us. This resultant normal contact is what I'll show like this. The total net force should be along y-axis. That net force on the pulley should be in this direction. The weight of the pulley. Hope everyone is able to understand the diagram. Now, how to manage after this? Okay, I think for first year, let me do this one. Cos theta. What is cos theta? We can write root of L/2 whole square, x/2 whole square by L/2. Please look at the diagram. Should be equal to weight of the pulley plus weight of the block. Okay, further, let's solve this. So the expression for tension will be equal to, I think 4 will come outside, 2 get cancelled. So this will be 2 weight of the pulley plus weight of the block length by 2 root of L square minus x square. This is a primary equation. We'll keep it. Okay, I think 90% of problem is over. Let's look at only on the rope. bring only rope. Bring only the rope. Once again, how tension will act like this. Then the here the who will balance that particular normal contact. This will show here. And it will subtend an angle. This angle, let me call phi. The radius of the pulley is r. This is given. Now, shall we go for again? Who will balance the n to t? Okay, this angle will be pi. This angle will be pi. So 2t sine pi should be equal to n. We don't know sine pi. What to do with sine pi? Again, on the pulley, I'll show separately here. On the pulley, the forces acting here will be in this direction. Now, already I shown. Once again, I'll put it. So this will be the arc length. And what is this total angle subtended? 2 pi. This is r. So what is arc length? Is s equal to r into 2 pi. 2t sine phi is equal to n. What we have brought it. So here phi will be. I'll replace in this way. Hope everyone is able to follow what I am putting. So this phi, now you can write s by 2r. Okay, what was the question? Let's go back. How much normal reaction per unit of its length does the string apply on the pulley? Tell me what I should take here. What I should search? That n by s. This n by s is what? That is being asked. So normal reaction per unit of its length. Per unit of its length. Normal reaction per unit of its length applied by string on pulley. So this is what n by s. Do we know t? Do we know t? Yes, the value of t is there. So that I'm going to substitute. So what is the conclusion? Even when a string comes with a pulley, there will be a interaction force between them, practically. That was the normal contact we can see here. Because of that, if I bring elasticity, I think it will become very, very big problem. This will be your answer. You will get answer. You can work out later on. I'll go for the next idea. Please do revise. I think we don't have any discussion in anywhere in the books here and there. So all possibility of asking in advance directly. Rudransh Agarwal, I think you can contact Manideep. He will help you. You can contact, I'm in class. One more. Read the question meanwhile. Okay, yeah. An arrangement set up in the lift is shown in the figure. The pulleys and threads are ideal and massless. Blocks are M and small m and capital M. Find minimum acceleration for which the thread remains taut and both the blocks accelerate in the same direction. I think simple constraint, they don't, let's not bother about constraint equation. If you check the advanced paper, we don't have anything on pulley constraint. They may not go for many pulleys and strings here. But questions like this can be asked for. They're just based on very simple idea. Number of pulleys and strings will be very, very less. Almost, I don't think so that is very important for. In fact, books they have shown like plenty. Both should accelerate up. What are the conditions like? What is the minimum acceleration? That minimum word also we have to justify it. Okay, read the question thing. I'll set the diagram. Okay, I think this will be sufficient. Yeah. Now looking at this diagram, acceleration of the lift. Put it here. Acceleration of the lift, or just write A is enough. That is. Then any forces that are acting. If this is a tension T, this will be T. This will be T. This will be 2T. This will be mg. This will be mg. This is T. Then how both the blocks has to move up. That was the condition. And what is the acceleration? We don't know. Call it as A1 and A2. Okay, this is something which is going to help us a lot. Some point P I indicated. I'll indicate by green color. Now don't fight with constraint equation. You know, if acceleration of this point, how it is related to acceleration of these 2 points on a string. I think directly we have a formula. And what is the acceleration of this block? Should be the acceleration of this point. So therefore, acceleration of this point of the pulley, it is in fact connected. And now first equation is what I'll write it. A1 plus AP by 2 equal to A. I think everyone knows this. How the acceleration of the pulley and acceleration on either side of strings are related. So therefore, this A1 plus AP equal to 2A. Then similarly, let's come for this one. Acceleration of this point. And how it's related to acceleration of this point. What is acceleration of this part of string is equal to acceleration of lift? Acceleration of point P, we don't know. Acceleration of block, let it be A2. So therefore, AP plus A by 2 should be equal to A2. AP plus A by 2 equal to A2. Okay, this is about accelerations of this one. So we'll eliminate AP. We'll eliminate AP, then we'll get relation between A1 and A2. Subtracting these two will be 1 minus 2. A1 minus A equal to 2 minus 2A2. A1 plus 2A2 equal to 3A, or A equal to A1 by 3 plus 2A2 by 3. Keep it equation 3. Let's write the equations. T minus small mg, small ma1. Then 2t minus capital Ng equal to ma2. This a1, a2 will substitute in that equation. The equation 4, 5. Put 4 and 5 in 3. So this will be A is equal to 1 by 3 T minus mg. A2 will be 2T minus mg. So we'll solve this, we'll get exactly, but we don't know T, no? Okay, let's see what will end up. Okay, this will become T by 3 1 by m minus g. What to do after this? I think till here everyone will end up, okay, something like in constraint equation all. After this, what to do? So look at, let's go back to the condition given. The string should be taut and the block should accelerate. For the blocks to accelerate, what is the minimum condition here? This 2t should be greater than or equal to mg. So 2t equal to, let it be equal to mg, then we'll get minimum. For the string to be taut and the block to accelerate, tension should be non-zero and it should be greater than or equal to mg. So what is the necessity condition? 2t must be greater than mg. As a becomes minimum, so therefore 2t equal to mg, you write it. So that value substitute will get acceleration. Really, the last part is what we have to struggle a lot. And if I solve this, acceleration is equal to so how it is positive, no, in fact, will be upward. I'll write it here. This is the idea which will trouble you a lot. Please think on it. Okay, so simple constraint equations can be asked, nothing big. Okay, make observation. Let's go for next one. One more tricky thing. So some small idea will be there in a problem. That idea is what has to be taught, like previous one. So what to do with the tension? So these things is something I think matters a lot in exam. Get into the, read the question. Oh, it's really very hot. Huh? I don't have electric power. With mobile data we are running. Almost taking bath, sweat bath. Yeah. Find the range of value of m in terms of capital M, small m in terms of, and the angle of inclination theta, so that when the upper block is released, the lower block starts sliding up the wedge. So at any cost, the lower block should slide up the wedge. So if you want, for our diagram purpose, it's not that they go and collide. We will only shift this block. We can't shift. I'll bring another one. Why to fight with it? Yeah, here we'll draw it here. It's a bit easy for us to draw. Describe the diagram, because there at the edge here, no, indicating all will be problematic. Okay, this is what is telling this smaller block M. So what it should slide up. The lower block starts sliding up the wedge. Actually, it should be here only. I should discuss it, but all the things indicating here will be big headache. So I just kept it here. The moment you release, so in what direction this wedge will move? Another block is telling find the range of values of M. So definitely this should move up. So then O will make it to move up. So I'll start with this one. So here the moment I release, what are the forces acting? mg sine theta. Normal reaction N1, then N1. mg cos theta. This N1's component of this normal reaction, what it does, it will exert force on the wedge in this way. Oh. So because of this, the wedge will move in this way towards right. Sir, you can ask primary question. Sir, here also block is there. It will also exert a force. What's wrong here? This also will come into picture. No? N2. Then because of N2 sine theta, because of N2 sine theta, the wedge will also move towards left. But what is the primary condition given for us? This smaller block should rise up. So for that, the net force on the wedge should be towards right. But are you sure? Look at the wedge. One more troublesome. Wedge is having any mass? Light material. Okay, now this is massless. So what should be the N1? N1 should be equal to N2. No doubt. Okay, later part, this is going to help us a lot. So here N1 sine theta minus N2 sine theta equals 0. Why it is 0? Because now mass is 0, but it can have acceleration. So therefore, rather than writing it, I'll end up some mass of the wedge and A naught. As wedge is massless, so you have very good problem. It is wedge is massless means M naught 0, but acceleration will be non-zero. This is a very primary important condition. A body which is massless, can it have acceleration? That's what the example is, what I wanted to bring here. Are you noticing this? This part is something very important for us conceptually. What do you think? Okay, light body should not accelerate. Light body also will accelerate. Let's get into the next part. So we'll write all the possible equations. So pseudo force will act here. MA naught. Then other forces that are acting are mg cos theta. What makes the small block to slide up? MA naught cos theta should be greater than mg sin theta. Find the range of that was there. So we'll take the minimum at least. So MA naught cos theta equal to mg sin theta. So A naught equal to g tan theta. This should be the acceleration of wedge. And for what is further, N2 is equal to N2 minus mg cos theta minus MA naught sin theta equals 0. Solving this, A naught is what? G tan theta. Solving this, I think you know all these are some very standard things. Instead of doing all this, you could have written directly A naught and N2. Okay, fine. After this, let's look at the let's look at the wedges. Anyway, we have concluded already N1 sin theta, N2 sin theta, but still the value, find the ranges of values of M in terms of M and theta. Small m should come in terms of capital M and D. Any equation can we bring? I think I to just give some time for students to think. Okay, I'm asking you to look at this block. Okay, look at here. As the wedge is sliding, what is the motion of the block? It will move somewhere in a plane like this. But with respect to wedge, how it will move along the incline? So is there any relative acceleration between the block and the wedge perpendicular to incline? The answer is no. So there is no what we can write. There is no relative motion between the block M and wedge along perpendicular to incline. So therefore, so what we can write based on this I'm going to write N1 minus M1G cos theta minus M1 A0 sin theta. This you should know how to justify it. Is it N1 minus M1A not sin theta or plus M1A not sin theta? I think there is actually, this will be wrong. If I write it in this way, it will be correct. Now, sir, from where you have brought this equation? I think this is the main important part of this problem. Pseudo force, I applied a pseudo force. Nothing is there. That pseudo force, let me. So MA naught N1 sin theta should be equal to M1G cos theta. Why it is like it? Because there is no relative motion between the block M and the wedge along perpendicular incline. So I got now the value of N1. So what is N1 equal to? M1G cos theta minus M1A naught sin theta. This is equation 3. I think okay, we are at better place. There's a constraint, wedge constraint is what? I have brought it. So solve 1, 2, 3, you'll get the required answer. And N1 equal to N2. We will write it. I think complete problem is there. N1 sin theta minus N2 sin theta equals 0. Therefore, N1 equal to N2. This is the equation 1. We will change it. It will be 3 and call this is equation 4. So solving 1, 2, 3, 4, we'll get the required answer. So what should be the mass of the block? Should be equal to small m. What is this? Small m it is. Small m. This small m, this mass of the M2 should be less than or equal to M1 cos theta, cos 2 theta. Solve it, you'll get this answer. How do we get solving 1, 2, 3, 4? So I think the green color, what I highlighted is something very conceptual, which will help us a lot. The green color one. This is something very fundamental. that in theoretical somewhere is there. So that's why I just took one example itself so that you can see that. I'll move to the, okay, we'll discuss that. There's one more very simple fundamental thing. Read the question. Likely we should get into what are the various forces that are acting. The tension T will act here. Normal contact between the block A and block B, here normal contact. The weight, small mg, here capital Ng. Then this is normal contact from the ground. What is the possible way in which the wedge can move? The wedge will definitely move like this. A2, I'll write it. What is the possible direction in the block should move? The block should move somewhere here. So why you are giving, because I think definitely it will try to describe, so it's a pendulum, no, simple pendulum. It will try to describe a circular path. So the normal contact between the block and the wedge N1. String is taut, tension. Just find the acceleration block B immediately after it is released, just after release. Just after release, I think, sir, they will lose contact. N1 should be 0. No, just after release is telling. No, I think the whole problem will become very simple. This is small m. Just for our convenient purpose, I just separate it. This will have the acceleration A2. This will have acceleration A1. This is a string along with the tension will act. I'll show it. Let's get into the discussion. Small m, capital M. I think let's be alert that also the symbols. These are the tensions. Any constraint equation? A1 cos theta should be equal to A2. Any reason for that? Because the moment you release, there will be normal contact. Because of normal contact only, because this block A will push the wedge B, then it will move. Otherwise, not possible. So therefore, the moment you release, there will be acceleration of the block A and also the wedge. So therefore, the constraint equation A1 cos theta equal to A2. The reason for that, the normal contact N1 is 0. Acceleration along common normal must be equal. So don't think that wedge constraint means something very big, where all two surfaces come in contact, and if they have motion, let it be in any direction that they move. Since they're in contact and they're in motion, then acceleration along common normal must be equal. Where all you want, you can apply this. Not only like triangular, some block, anything, any surfaces. Two surfaces are in contact, and if they're in motion, then acceleration along common normal must be equal. I think your wedge constraint is over. We need not to do anything because everywhere we'll be using same thing. What is the state of block? How the block will move? Block moves in curved path. Block moves in curved path, we'll write it. And how the wedge will move horizontally. Let's write all the possible equations. Now it's a very simple. So what are the equations of motion for the block? This is N1 I to show it. No? N1 equal to ME2. This is one thing. Then for the block, any equations can be write along x-axis. It should be T sine theta. What about the tension? We'll describe the motion along A1. Along A1, it will be small A1. There's also again will W. Mg sine theta minus N1 cos theta. See this? This will be theta. I'm describing the motion of the block perpendicular to string. So what is this and the whole equation? Motion of block perpendicular to string. And now one best question student can ask, sir, why not along the string? Anybody wants to answer? Why not along the string? String is inextensible and it should be tau. If you say that block will move like this, tension becomes 0. If you say the block will move away, then it will become extensible. So therefore, we are describing the motion of the block perpendicular to string. Motion of block perpendicular to string. As why only we should think like this? As string will be taut and inextensible. Finish all. I think 3 equations are there unknown. 3 unknowns are there. Solve it. Theta is given for us. I think we can solve. A1, A2, and N1. 3 equations, 3 unknown. Solving this will get the required answer. I'll write down the answer. Just it's a mere simple calculation. Acceleration of the wedge is asking, no? So M small m sine of 2 theta see, I think do remember that this wedge constraints idea is something very fundamental. I have one more. I think, yeah, we'll finish off this, and this will be a little bit. I'll read the question. Find the acceleration of the wedge. We have also string into the picture here. We'll assume M2 greater than M1. So definitely the wedge inward action will accelerate. A little bit lengthy. Just let me share at least the idea. Read question. Meanwhile, I'll just set the diagram. Let's get into the discussion. I think first free body diagram. There's no other way. Getting the free body diagram. So free body diagram, the various forces that will be acting here. M2G sine theta. String will become taut. M1G sine theta. Then normal contact N2. Here on the wedge. This will show it. N2. Then normal contact here N1. M1G cos theta. This is M2G cos theta. Then here the normal contact N1. Now what action will assume the wedge to move? So that the wedge will, in fact, will accelerate in this direction. Then in what action pseudo force you have to bring? You have to bring pseudo force. Tick tick arrow, you show it. That is MA. Pseudo force here also M2A. Then describe the motion of the block wedge. But here is asking to get the acceleration of the wedge, no? So can we describe the motion of the blocks relative to wedge? Yes, you can bring AR also. One more, the same thing. You can describe. So here what we are describing the motion of the block with respect, I think, okay, not needed, no? Why this one? So let's write the equation. Let the acceleration of the block be AR. It's mere writing equations, definitely will end up the answer. Write all the possible equations. How to describe the motion of the block? It will be perpendicular to incline, will be N2 plus M2A sine theta minus M2G cos theta equal to 0. This for the block M2, perpendicular to incline, parallel to incline, T minus M2G sine theta minus M2A cos theta equal to M2AR, equation 1, 2. Then for the other block, M1G sine theta minus T minus M1A cos theta equal to M1AR. What is AR? What we should write AR? Acceleration of blocks relative to wedge. And what is a acceleration of wedge? A good question for students to practice rather than for exam point of view. Then perpendicular to incline for the block N1 minus M1G cos theta minus M1A sine theta equal to 0. On the wedge, how you write equation? I think that the first time you are brought, we are bringing tension also acting on the wedge. Till now, we didn't add any, most of the problems, we didn't add that tension acting on the wedge. Still, shall I say that it is N2 sine theta minus N1 sine theta only? Oh, now, at this particular stage, you should write equations in this way. But sir, tension is also acting as component of this tension. How much it will be? T cos theta, here T cos theta. Both will you can say, will nullify here. So here N2 sine theta, N1 sine theta. Since N2 greater than N1, so therefore it will shift towards left. Solving all this will get the answer. But he's asking acceleration of the wedge. This is A. But sir, we don't know AR. I think AR can be eliminated. How to eliminate AR? How to eliminate AR? So substitute this 3 into, we'll get T. We'll get expression for T. But anyway, the T is not needed, no, for us. Okay, substitute AR into this one, you'll get T. The tension distinct that is nowhere related. Okay, but we wanted acceleration of the wedge here. This is N1, N2, we don't know. So we'll do one thing, directly put 1, 4 in 5. Expression for N2 and expression for N1 in this. get acceleration. After getting acceleration, if you want acceleration of the block, you have to work out how to work out acceleration of the blocks. I think this is something very important. So you treat like there's a wedge. Only first look at the block M1. Only look at the block M1. Don't at a time you take it. So this is the acceleration AR and this is A. So therefore, the acceleration of the block A1x AR cos theta should be equal to A1x minus C. This is the acceleration of the block with respect to ground along x-axis. Similarly, AR sin theta equal to A1y. Hope everyone is able to understand what I mean to say. Sir, what is this? AR is acceleration of the block with respect to wedge along the incline. Component of that AR cos theta is equal to acceleration of the block with respect to wedge along x-axis. Should be equal to acceleration of the block with respect to ground along x-axis minus acceleration of wedge. Try to see the signs now. Now for this, it will be a little bit different. For the other block, very good question. You can learn so many things here. And the wedge is moving like this. How do we write here now? How do we write here? So it should be equal to now AR cos theta AR cos theta should be equal to A2x minus A naught or A naught or A only we took it. Yeah. Again, we'll get A2x. Then what about AR sin theta? AR sin theta, what shall I write? Equal to A21. Solving this A1x, A1, once you get AR, rest all everything we can find out. Why this wedge constraints means in one problem, you're going to learn so many things. That's what the advantage of wedge constraints. If you take one problem, there are so many things will be involved. At a stretch, what will happen if you do 10 wedge constraints, almost you're doing 150 problems. That's why they are given a little bit some priority in advance also, rather than asking some things. So just they'll put wedge constraints. So all the constraint equation is there. Laws of motion F equal to ma is there. Then wedge constraints will come into picture. Then the idea of normal contact, tension, all things can be included here. Okay, we'll wind up the class. Thank you, all of you. Okay, thank you, all of you. I'll stop.